Hey guys, we're going to talk about constant acceleration. So far we've talked about speed and velocity and what these things mean. And so here's some definitions of those two things, right? We're going to do a little practice with graphing here before we get started talking about what acceleration is. So here's some graphs. These, well, first of all, when you look at a graph, you have to know what type of graph it is. Okay. So for these suckers, since there is an x on the y-axis and a t on the x-axis, these are displacement time graphs. Sometimes instead of an x, I put a d, but whatever. So these graphs are showing you our displacement in reference to the time. So can you qualitatively describe what's going on here? And by qualitative, I mean in words, say what's going on here. Maybe it's a person walking, maybe it's a car driving. What's going on in this first graph at the top? Try it. So in this first graph here, the object starts at position 0, which we call the origin. It's moving in a positive direction. Anything above this x-axis is the positive direction. The velocity is constant, and how do we know this? Because this is a distance time graph. There's a couple ways in which how we would know that. One is the slope of a distance time graph is velocity. It's distance divided by time, or displacement over time. Okay. So the slope would mean velocity. How do we know that it's constant? It's because it's a straight line. Try the second graph. So in the second graph, the object is starting away from the origin, so that would be here. Okay, this is a car that's starting away. Let's say maybe the origin is a stoplight. So they're starting to the right, the positive side of the stoplight, and they're moving in the negative direction. They're moving left towards the light with a constant speed, and their constant speed ends when they get to the light. So you could say that this car is moving away from the light at a constant speed, and you could say that this one's moving towards the light at a constant speed. Okay. There's two more graphs. Can you do the top one? What's going on there? Does it start at the origin? It does not. What's it doing? What kind of slope is it? What does it say? So here it's starting to the right of the origin, and it's moving in the positive direction away from that origin with a constant speed. About the bottom graph. On the bottom graph, it also does not start at the origin, but it's going to move towards the origin because it ends up on this line here, which would be our 0 mark. Right? So here it starts to the left, it's moving in the positive direction, and it has constant speed. So these are some of the things we're going to be able to try to do, and you probably will see these on the AP test. So this is the thing you'll have to worry about on that test. So for a distance time graph, the slope is velocity. And the nice thing about a straight line is that whether you're finding the average or the instantaneous, both will be the same, okay, because it's a straight line. All right, that's the thing. Instantaneous velocity is the velocity right now. And we talked about this in one of our previous videos where we were driving from here to Waco and talking about you can figure out the average speed over the entire trip, but that may be different than all the individual speeds as you drive. And how fast were you going when you passed that Starbucks 2/3 of the way into the drive? That's called instantaneous speed. And the nice thing about a straight line, as long as you have a straight line, those two things will be the same. So if I asked you, how fast was the person going at 2 seconds? Well, That would be right here on the graph. Yeah. All I really need to do is find the slope of this line. It will tell me the speed, both average and instantaneous. It will tell me both. That's really nice. So knowing what the type of graph is, knowing the slope, these are important things to be able to do. Now, second type of graph is called a velocity time graph. So now we're not graphing distance, we're graphing speed. So what's going on in this top graph? It's a velocity now. Some people are apt to say that the velocity is zero. Velocity is zero. It is not. Zero velocity would be right here on this line right there. So say this is a car or something like that. It has some speed, but what do you know about that speed? The speed is the same every second. It's like it's stuck at this spot on the y-axis. So this thing, maybe it's a car, is moving with a slow, constant speed. It's like the car's on cruise. It's a slow speed because it's not very far above the 0 point. What about down here? What's going on there? Same deal. It's moving with a constant speed. It's moving in a different direction, but it still has constant speed. So positive and negative, whether you're above or below this center line, will tell you which way. So let's talk about this. What happens, let me go back one. What happens if this is not a flat line? What if this line goes up like that, has a positive slope? What does that mean? Well, that means your speed has changed. I'm going to call this acceleration. This is the definition. This is a fact. You can write this down on your list of facts. Acceleration is the change of velocity. That's it. So what happens is people misunderstand this. We humans have created all these terms for different things that happen. And we've created these words, deceleration being one. And I'm here to tell you right now there are only 3 ways in which you can accelerate. These are more facts. If you increase your speed, you have accelerated. If you decrease your speed, if you slow down, you have accelerated. You heard that right. And if you change direction. These are all ways in which you accelerate, because the definition is change of velocity. That's it. So if your speed goes up, if it goes down, you have changed your velocity. If you change direction, this one is a little harder to see, but I hope it makes sense. If you're in your car and you take a turn really fast, you feel like you're being pulled, like your body's being pulled to the outside of the car, and you're forced one way or the other. You feel a force. You feel something. And so that's how you know that you have accelerated. So even if you take a turn in your car and the speed doesn't change, you still accelerate. Fact. To calculate, you find the difference of your initial and final velocities and divide by time. It is a change in velocity over time. And here's the thing that can happen. If you increase your speed, if you're at the light and the light turns green, you hit the gas, your final will be greater than your initial, and you will get a positive number. But if you're coming up to a light and the light turns red, most of us would hit the brake and we would slow down. It's a good thing to do. So in that case, if you slow down, your final speed will be less than your initial speed. And the number you get here will be negative, and that's okay. That negative is confusing to a lot of folks. Last week, I asked in a little game that we played on the first day, is it possible to have your force going one way and your displacement go the other way? And this is a great example of that, because when you come up to a light and it's red, you should hit the brake. And when you hit the brake, which way do you go? Well, you're still going towards the light, but you're slowing down. That's because there's a force acting on you in the opposite direction. And that's why you get a little minus sign if your final speed ends up being less than your initial speed. The units are meters per second per second. And instead of saying meters per second all the time, I just say meters per second squared, because it's meters per second. And those two seconds are multiplied, right, because velocity has time in it, and then it's divided by time. So meters per second squared. So there are 3 ways in which you can change your velocity. You can increase speed, you can decrease speed, you can change direction. Sometimes you'll have more than one going on at the same time, and this is a thing. Now, can you do this? What if we don't have flat lines? What if we have, this is a VT graph, and we have this positive slope? What does this mean? What's happening here is that maybe it's a car. The car is moving to the right in the positive direction. The speed is increasing because it looks like it's starting at, this is our 0 point, and it's increasing from 0, right? This would be a positive slope. It's a straight line. Because it's a straight line, our acceleration is constant. How do I know this? What is the slope of this line? What is the slope of this graph? What happens when you take rise, which is v, and divide by run, which is t? What is v over t? V over t is a. So the slope of a velocity time graph is acceleration. Write that down. The slope of this graph and this graph and any VT graph is a, acceleration. So maybe this is a car. It's starting at rest. It's increasing its speed in a constant way. What about this car down here? Same thing. It's increasing its speed. This one's harder to see. People think that, well, if it's below this line, the speed's not getting bigger. But this is my 0 here. And now, as I go, I'm getting away from that 0 point. I'm getting further and further away from it, which means I'm increasing my speed. But what's different? Direction. Both of these show increasing speed, but this one has a direction that's in the opposite way. Can you draw graphs that correspond to this situation? What I usually do is I pick one of the graphs to draw. Usually I find that actually the VT graph is a lot easier to draw here. So I would draw this one first. The car stopped at a light, so that means I'm at 0 here. And then it's going to accelerate at a constant rate and increase its speed. So my guess is I'm going to have a straight line going this way. The harder graph is this top graph. As the car picks up speed, what happens to the amount of distance it travels every second? Well, that goes up more and more every second. So you get a picture that looks like this. And we have a curved line here, which we really haven't seen yet. Does this make sense? If my speed increases, I am hitting the gas, then that means initially I don't move very much. But as time goes on, my car picks up speed. I'm going to move more and more and more. And my displacement is exponential.